We have seen yesterday that we can input our data and then we can start to visualize it. And by the visualization, we can also take in and out a bunch of mistakes. So we can see that we have a problem, a mistake, an error that is being called right here in the OL geology. This error is actually attached. If we open it, this error is attached to the lack of information right here. So for us to take a look here, let's present the option that we can just unvisualize the GM phase 1, or we can take it out. So if we come closer, we can check out that our problem is on our drill hole for OL14A. So you can just click here and you will see that it's the OL14A. And what we know about the OL14A is the one that we also had fixed the survey. So the problem is about the lacking of data right here. But we can also see that this is a survey deviation that it's not making sense along with the other deviations that we have. So what we are going to do, we are going to take a look directly on the survey. So opening the survey right here, we can see that there is a segment that is right from the OL14A that was ignored. So what we are going to do, we are going to untick it and save it. So now that we have unticked and save it, you could see that we have changed the group lithology and the interval selection lithology too. And by consequence, we have also changed everything that is inserted in our geological model, the phase 1. What I wanted to show you right here is that everything that we change right here on the first relationship of our data is going to change everything in our data. So if you want just to take a look what this geological model is attached to, we can just
Excuse me,
right click
Julia.
right here, see the relationships, and now we can see the inputs on it. So what that means? That means that all those things, all those parameters right here, if they are changed, so if this is changed, if this is changed, the model will change. If this changes, if this changes, if this changes, the chronology will change. So, and this ways goes on. So now we just need to close it because what I wanted to show you is how important it is for us to be aware of the process that we are following. So right now we are in the first stages of a project. This is not very much concerning. You will remember what it's related to what, but on bigger projects or on big data sets, you will not. So you have to check on the relationships view so you don't have any problem. So now that we have already corrected our drill holes, what we can see now, we can start to actually do some interpretations about it. But one thing that you have probably also realized is that my colors are not the same as your colors. So how we could make everyone with the same color, we have here an LFC file that is already the colors ready. But I wanted to show you, if you want just to edit the colors afterwards, you can. So if you want to also afterwards just export these colors, we can too. So at this moment, we are just going to import our color. So this way, we are just with the right button coming back to our project tree. And at first, we are going to take a look in the stratigraphy. And we are going to right click on it. On the colors, we are going to import. So on the right click on it, on the stratigraphy, colors, import, and we are going to go for our Leapfrog Gel Fundamentals course data, and we are going to go for our data that we have right here. So let me just open it. It's importing. Let me see. It's right here on the original import. So importing drill hole data, original imports, and we will be able to see the OL drilling and the simple lithology and stratigraphy. Right now, what we are going to do on the stratigraphy. So let's click on it and open. Now we have new colors imported, and we are going to do the same for the simple lithology. So we are going to right click on simple lithology, colors, and import. And we are just going to click on simple lithology and open. Imports complete, the new colors have been applied to all the 6 codes. So what that means, you could see right here that we could also export it. So if I had settled a right pattern of colors that I wanted, I just needed to come right here, right click on it, export it, and then I can move that along with my project. So if somebody wants to have all the same visualization as me, it's possible and pretty simple to do. So now that we have checked already what we have here in terms of um, errors and grouping and selecting, now we are going to finish our interpretation because we have now finalized all of the drill holes, and we just need to see on the legend what we have and change right here to the stratigraphy, editing the colors, make everything visible, and just clicking on the OK. Why? Because now we are just going to click on the cylinder. And by clicking on the cylinder, I also wanted to mention that we can select categories, select the line radius. So let me change this for you to understand what is changing. You can see that the radius of this cylinder is way bigger, and this is some of the functions that we will have for this kind of visualization, that it's to make you understand better your data. So you can select from the scene any column of the geology that you want to see. So just remember, everything that you are seeing down here, it was a column that we created. So if you want to select or do new categories, how you are going to do that, you just create a new column. So from a new column, we could group the lithologies, that what we have done with the granodiorites. We can make the interval selection, that is what we are going to do with the dike. And also we can create evaluated columns, measure category colors, category from another table, and also to import new columns. So if you want to just add more information here, we could also do that by importing a column. So now that we have here the stratigraphy, let's check out the colors individually. And why? Because we want to understand better what we are doing. So we know that the granodiorite should be together. So that's why we have already advanced to our new lithology, that is the grouped lithology. And now I'm just going to insert everything for visualization. Always remember to do that when you are dragging back anything from your view. Why? Because if you are going to open or other person is going to open afterwards, it may not have the full visualization and keep wondering why, and it's going to be just the matter of viewing. So just clicking on the OK, because now we are going to take a look on the grouped lithology. Why? Because we have here the grouped lithology, that is our model already interpreted, if we look this way, that it's interpreted by the granodiorite. So we have done a step that was interpreting one group of lithologies. If we wanted to group another lithology, we will do that in the same column. If you don't remember what I have done yesterday to group that, we just have come right here to the OL geology, new column, and group lithologies. So if I click right here, I would just need to input the source that I'm taking from, and we could group this lithology. So after that, we have checked the interval selection. And why the interval selection is important? Because now that we are seeing the grouped lithology, let's just take a look on the colors again. Why? Taking off the overburden. What is the overburden? The overburden is this first layer. So we are taking off the overburden just to understand that if we are talking about the youngest lithology that we are seeing here is the overburden. And this information is important. So be aware that if you are trying to do a new model, you need to interpret your data also so you can build what is making more sense. And we are going to enter a little bit when we really start to model that I'm going to speak a little about the 5 golden rules that we have on the modeling, but we are going to answer some questions about our data with the visualization on the program, and then we will be able to start our modeling. So now that we have checked that the overburden is the youngest one, we can go for another one that we know that probably it's going to be one of the oldest. That is the QPZ. The QPZ is a quartz porphyry. So quartzite. So we can just take this out and we're still going to see what is happening right here. And now we can just take out the granodiorite because we know that was already interpreted. And now that we have taken out the granodiorite, we can take out the stratigraphical sequence that we have here. That is the D1, D2, D3, D4, and D5. And what we have when we got this, we have a vein and a dike. The dike I have already mentioned yesterday that this dike right here, it will need to be splitted, right? So when we are talking about a modulation that will need for the dikes to meet, we are going to model it as two veins in a system vein. So this vein right here is just a single vein. And this one right here, we are going to model as a system of veins. And how we are going to make the program understand that we are doing these two different dikes, we are going to do that by the interval selection. So now I'm just going to take everything out here because we are going to open the interval selection. So when we right click on the interval selection right here that we have created yesterday, we have our toolbar again of selection. So what we are trying to do here is just to select what we want. So to do that, let's just visualize what we want. And we are going to visualize just the dike. So we have here the dike. And what we are going to do now, just pressing D, we will be able also to make a slice. So I had pressed D and now I am drawing a slice. So on my slice right here, I can see exactly what I wanted to select. So what am I going to do? I am going to click on the selection by line. So I'm going to select these intervals by line. So I'm going to select this, 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 and this. You can see that this is a straight line. So we had selected. After we selecting, we just need to come right here, assign to. We are going to expand the assign to, and we are going to create a new lithology. And this new lithology, it's going to be called dike 1. So the vein of dike on top, it's going to be our dike 1. And we are just going to click on the OK. And now that we have selected the dike 1, let's select the dike 2. Now, the same process, assign to, create a new lithology, and this one is going to be the lithology dike 2. And we are just going to click on the OK. So, now we have done this for one site. We wanted to do this for the other sites. And I already have my slice here. What are my options? I can just come to the slicer that it's right here, and I can click to see the other side of it. And this way, I am going to come closer again, and I'm going to select it all over. But this time, the other side, because I know there was two sides of it. And now I just need to assign to my dike 1 that I have already created. And now I just need to do the same for the bottom one. That is going to be our dike 2. So I'm going to assign to our dike 2. And after this being finished, I can just take off the slicer right here on this X, and I can see my selection. So now that I have all my selection done, I just want to save it. So before I save it, I just want to be clear that everyone was able to select the two bodies, and there is no doubt on the toolbar right here that we are seeing. So if you want a wider line, you could just by pressing right here. So just carry on. We just need to save it. So now just saving it, and we can see all the visualization again. So now what we have right here, we have a simple little grouped interpretation lithology. And this interpretation lithology right here has two different dikes. That is what's important for us. So this interpretative lithology right here have our two dikes. So there is any doubt until this moment? I just want to be sure that you are all following up.
Yes, Julia,
So
hi. Yeah, it's fine till now.
okay, so now you have realized that we did a grouped lithology, and on this grouped lithology, we had our granodiorite together. And right here in our interpretation lithology, we are not having it anymore. So how we could fix that? We could do it over again. So we can do a grouped lithology and afterward do the interval selection all over again if this is what we want to and this is the result that we are trying to get. So we are just going over here because the stratigraphy, the interval selection right here, oh, sorry. This is something that I wanted to mention with you also. You are going to have in general 24 hours for your connector. So what it had open, it had open here for me to make the selection again because it had reached exactly the point that we had started yesterday using the license. So I just need to input here the get started and done. We have here our software open again. So now let's just coming back to what we were talking. The interval selection that we have done right here, it's based on our pure stratigraphy. So what that means that we don't have our granodiorites grouped together. So let's do it all over again. We are going to delete the interval selection to redo that. And on the grouped lithology, we are just going to take a look on it and see if our granodiorite is totally together. We are just going to take the visualization of everything and input the visualization of the granodiorite. So we have this already done, and we just need to click on the OK. So on the grouped lithology, on the OL lithology, we just need now to do the new column, and in this case, the interval selection with the base column being the grouped lithology, and the name is still the same, is the interval selection for the lithology, where we are going to make the selection of the dike. So this is another opportunity for you to do the interval selection of the dike. Why am I saying that? Because I know that it sounds pretty easy when I'm doing here, but this is something that you need to practice a little bit. So after you get it how to do the selection, you will see that this is way easier than QGIS or RQGIS or any kind of GIS selection tool. It's just that you need to practice a little bit the parts of this slicing because we are seeing everything in a 3D environment. You need a certain practice just to understand when you are drowning something, what is happening to this drowning, what is actually splitting or not splitting. So that's why we are going to do all over again this little workaround about the interval selection because you're going to use that a lot of times. So what we had to do right here to start our interval selection, see only what we want to select. What we want to select, the dike. So now that we have these two sets of dikes that we know that the
Hi,
first one belongs to one body and the
excuse
other
me.
one belongs to other body that we want to be
Hi,
veins
Julia. Can you
and
hear me?
veins that are bifurcating for the same place. How we are going
Hello.
to do that? Sorry?
Yeah, can you hear me? Yeah, Julia, this is Harish.
Sorry, I am not hearing pretty well. Could you again?
No, actually,
Okay.
I was trying to make the interval selection, but it's only
Hmm.
legend is getting off and on, not the actual lithologies.
So when you were doing the interval select, you do the group lithology, right?
Yes, yes, I did the
Okay.
two.
So when you go for the OL geology right here, new column, interval selection, and here the base column that you are going to use is the group lithology.
Yeah,
Is
uh,
the same?
actually, license expired. Sorry, I have to start again.
Yeah, it's the same. That's what I was showing you. We will all get this in the same time. So because it's made for one day and to be renewed by day. So yes, we are going to get everyone in the same time, the expiration. I just have received it now. So mhm, you will need just to open the connector and
Yeah, I'm trying to open it again.
no problem. Just while you are opening there, I'm just going to carry on with the interval selection, finishing it, but we can come back because I think that your problem was right here. In the time that you were doing the new column for the interval selection, you probably had put on the base column just this thread, and we need the group lithology.
Uh,
So, mm,
we can continue.
so if you double click on the interval selection right here, how we are
Mhm.
going to do just to see the dike. It's here, this little eye. Are you seeing? We untickle and we can see everything at once, but we are going to untickle this and just tickle the dike because we want just to see the dike. You were able to do that part? So if we are seeing here the dike, what we could do, we could just do the interval selection right here if you want. So for me, it's kind of easy. You can just do the selection, assign to, create a new lithology, and this is going to be the dike 1. But if you want to do that in a more conservative way, what you're going to do, take a look, north. Oh, down, sorry. You are seeing down. Now that you are seeing down, what you want to do, you want to split your vision. Then you are going to split your vision. And right here on the slicer, you can see that you are just seeing, you are just removing the front. So you are coming back to your project and selecting the, oh, sorry. You are going back to your project looking at east and just select what you want, remembering that what is on top is going to be the dike 1 and what is below is going to be the dike 2. And now I'm going to assign and it's going to be the dike 2. And just click on the OK. And now we are just going to change this view from remove the front to remove the back. And we are going to select our dike 2 again. So after we've done that, there is any trouble now? I know that the interval selection is not the easiest part, but it's just until you get used to this editing toolbar. You could see it's easy to do. It's just the first times that can be a little bit trickier to understand how the 3D is being changed. So do you have any more doubts right here? Because from there, we just need now to save it and carry on. So I'm going to take out my slicer right now. And now we can see that we have what is necessary for us to be grouped. We have what is necessary for us to be splitted. And now we can actually start our surfaces. Why? Because this is one very important part right here to start our geological model. As I have showed yesterday, we need to understand how our model is separated into surfaces. So the base lithology column right here is going to be the interpreted lithology. The surface resolution, we are going to leave at 30. The unenclosed object is going to be the essays. So what we are seeing now that the essays are the boundary, they are really close to our data. This one is the best way for you to start modeling. Why? Because you are starting. If you're starting modeling, you are going to do several surfaces that are going to be first pass surfaces. So the closest you are from your data, your source, the easier it's going to get for you to understand and interpret if the program is taking the right direction for it. So we have already set our surface resolution to 30, but now we just need to check. Does it make sense for us to make a resolution to 30? How much it is the space that we have on our lithologies. So yesterday we have constructed this new geological model. If you have not changed it here, the interpretation, as I have done, you will still have the geological model. So it's basically the same. We have to choose a base lithology column. So this decision right here, it's very important. So we have already make a lot of um, new characterizations in our lithologies for us to be able to model it better. So what that means? That means that is no longer just the stratigraphy, is the interval selection lithology. That is the one that we have the grouped, granodiorites, and the splitted dike. So the surface resolution right here, we are just going to leave at 10. And one thing very important to mention here, every time that you reduce one by one your resolution, you improve by 4 your processing time. So the ratio here is 1 to 4. So 1 unity less on your on your resolution, 4 times more of processing. So just for you to be aware, if you are trying to model things that are less than a meter, expect to have a good hardware to handle that, because we will have a lot of processing happening. This is going to be the same as you trying to do a LiDAR image that has a really good resolution. Is going to be really heavy, the processment for the computer. So here we are just going to input phase 1 on our geological model. We have already enclosed our object. What are the options that we have here? We have already checked that, and now we are just going to click on the OK so we can start already to check our surface chronology. So you can see that our lithology right here, it's our interval selection lithology. That was the one that we have selected right here for our model. If you double click on top of your model, you are going to have this window right here, and this window is extremely important. Why? Because we are going to change several aspects of our geological model through here. We are going to start doing our surfaces, and they have to be chronologic correct. So what that means, that we are going to start to create surfaces, and then we are going to input right here these surfaces in the right order. If we have a background lithology, we are going to insert right here. And if we need to change, we are going to change with these two arrows right here. So the lithology columns are from the interval selection. The lithologies are the lithologies that we have checked. So we have the dike 1, the dike 2, and the granodiorite all together. We don't have any fault systems, but it's important for you to be aware that if you have any fault system, we could insert right here on the meshes. We could start as a polyline if we have this marked on a geological map, and then we could go from meshes and call it right here the fault system, a new fault. It could be already from a polyline or from base lithology, from other contacts, from GIS vector, from points, from structural data. So if you have just structural data on disks, and from a surface. So those are the several options that you have to insert also assist a structural system on your geological model, but we are going to start it with our surface chronology. So the boundary we had already checked. This is our little boundary right here that is attached to our essays. So on the general, we are coming back to the boundary filter and the snap to data. We can see that the snap to data at this moment it's off. We will need to bring this on because the snapping to data is how much the surface is going to actually pass through the point of contact. So for us right here, this is going to be important because we have this information and we want it to be respected. So now we have it right here, our geological model. We can start to think about our surfaces. We have already spoken that the first of one is the overburden. And why we are telling that? Because it's on top of everything. So if we just visualize the overburden right here, we could see that it's on top of everything. And on the options that we are going to have on the surface chronology right here, we will have some of them that will make more sense and some of them that will make less sense. So if we are talking right here about our surface chronology, just right click on it, we will have all the options. The first of options, the new deposit type. So when we are doing a new deposit, just imagine that is going to be a continuous depositional kind of layer. When we are doing an erosional, it's going to be very look-alike the depositional one, but once we activate this, it's going to deplete a little bit the previous surface, the previous volume, because it's an erosional surface. A new intrusion. So intrusion, we are going to use it when we have some kind of more robust and closed system or domain. This doesn't need to be exactly an intrusion, but everything that is kind of rounded and you want it to have a good control of this volume closed, you are going to do that as a new intrusion. So we also have a new vein. The veins are going to be used to do everything that is continuous and it's overlapping other lithologies. So everything that is narrow, continuous, and it's overlapping other lithologies, we are going to build it as veins. So for instance, you may be asking like, well, we have a dike. Why we are not doing that on the dike? Why there is no option for dike? Because the dike is following the same geometry as a vein. So everything that is narrow, continuous, we will actually model this as vein because it's probably cutting other kind of lithologies too. So when we are just talking about a stratigraphical sequence, we are going to do basically with deposits and erosion surfaces. When we are talking about domaining production, we are talking about intrusion. When we are talking about uh, getting Stockworks model, we are going to talk about veins. And what I wanted to enter now is the vein system. Why? Because we know that the dikes and the veins, everything that is narrow on the geological context, it also will be intricated. So what that means? That means that one vein is going to end in another or is going to start in another. So the new vein system is done for you to build your veins and to connect each other. So, and the new stratigraphy. The new stratigraphy we are going to use when we have exactly this scenario that we have here, that we already have a sequence that is kind of a layer cake uh, kind of modeling. It's just a cake with layers, and in the top of it or the maximum of it, you're going to have a little bit of erosion. We will see that for the D1, D2, D3, D4, and D5, this works. So let's just take a look editing the colors right here. And we can see that this is cutted by other by the porphyry. This is cutted by the veins, but this is a stratigraphical sequence. So now let's just talk a little bit about the golden rules that we have for modeling and after that, we just need to start. So the tips that I would have for you in for modeling on Leapfrog is first of it, and those rules here, they are very important to be followed. So if you don't understand any of them, just ask me again, because if you don't follow them, you will have problems in the future. So it's the same thing that I was telling about the errors. You can ignore the errors for a while if you are just trying to follow up with your workflow, but be aware that in some points you will not be able to carry on anymore. You have to sort out your first errors. So this is the tips that we have, the 5 tips that we have, so we don't make any error in the surface creation. So the first of it, do not generate duplicate points during the modeling process. And this will likely result in erroneous models. So we will discuss in more details this, because when we are constructing the surface, it's possible to see how many points of contact they have. But why this is important? Because when we are working in an environment with intrusive, potentially cross-cutting unities like vein dikes and intrusions, it's very helpful to start building your surface from the youngest to the oldest, so the cross-cutting relationships are honored. And why this? Because the building the surface from the youngest to the oldest, we are going to avoid generating duplicate contact points. So because we are following this rule is very important. So we are going to have typically to activate one fewer contact surface than our output volumes. So for instance, you have checked the volume that we have. We have here a full volume. So for us to separate that, of course, we are going to create more limits than volumes, because we are going to separate this volume, this full volume, in fewer volumes. They are our lithology. So we need also to experiment with different surface types as we are building our model. Why? Because you may find that one will work better than the other. Frequently, there is more than one suitable surface for modeling a particular unity, and by trying a couple options, you can pick which one works best for you. And in that scenario, with that particular unit geometry, so don't worry building up a few test surfaces. It doesn't mean that they will automatically create conflicting volumes in the model. So once you have built the surface, you will have to activate them to create the final output for the volumes on the model. And I have shown that once we open right here, we double click the GM, we can see right here on the chronology, this is the place that we are going to activate our lithologies for our model right here. So just to finish this little part, all the surface in a geological model can be copied. So you can copy all the surfaces and just do and try out another model if you want to do several tryouts. So we have reached now a point for our little break, and I'm just going to return in 10 minutes. Please tell me if you have any
Sure,
doubt
sure, Jimmy.
until this moment. Oh, sorry?
Sure, I said okay. Sure.
Perfect. So in 10 minutes, we will be back and we will start now to do our surfaces. And who knows that today we may finish all the categorical models. So let's see how it happens. If somebody has any doubt, just tell me on the chat right here. Okay? We'll be back in 10 minutes. So we are back. Tell me if you need a little extra minutes to fresh up if necessary. I have received a message from Marushi right here, and she is asking if we have a thin kind of interbedding, if we would model this by vein, and probably yes, but you need to understand if you want this with finite boundary or if you want this cutting everything. Because, for instance, if you are trying just to do some small deposits, it would be by intrusion. But if you want something that is continuous and it's cutting other things and it has probably interaction between it, we are going to do that by veins. But I think it's going to be pretty clear now that we start to do that. So let's start here to model our surfaces. And at first, I just want to make this a little bit transparent. And I want just for us to take a look on the overburden because we are just going to model this surface previews. So let's go to our surface chronology, right click on it, and we are going to build a new deposit. And this new deposit is going to come from the base lithology. What is the base lithology? The base lithology is what we had selected for the geological model. So we have to take our raw data, we have to correct the errors, we have to prepare this data to be used on the geological model with the right lithologies for us, and then we are going to start to construct our surfaces. So if I didn't have any information of drill hole, could I still do that? Yes, because we can catch this information also from a polyline, from GIS vector, from structural data, from points, from a surface. And what is pretty cool, this is a new tool set that we have, that this is from an offset surface. So what that means, I could choose right here topography and say that my overburden is going 10 meters above my topography, and this is going to be the surface that is going to be built for my overburden. But I don't want that because I have that on my base lithology. So we are just going to click on the new deposit from base lithology and just click on the OK. So if we want, this is an overburden, we could create this also as an erosion. So if you want this to take a little bit of um, the other lithology that it's coming previously, we could already done it by doing with erosion. But we are going to build here just as a deposit. I'm just thinking if it's going to make more sense as an erosion. We are going to build as a deposit from base lithology, and what is going to be our primary lithology right here, our overburden. So we are going to input overburden and we are going to select use contacts below. So right here, you can check the amount of contacts that those lithologies have with the overburden. So we don't want to duplicate those contacts anymore. So we could import inputs on the ignored lithology if we don't want to make contact with those lithologies anymore, but we need, because the overburden is really on top of everything and it's really making contact with everything that is above it. So we are just ticking the use below contacts. So this is an important part. Be aware of use contacts above or use contacts below. Treat unspecified interval as contacting primary, ignore it. We are leaving ignore it. A reference plan for it. So a reference plan we could set right here, a plan. So if you go right here up, we could set a plan and input that as a reference, but this is not necessary for us because we are here just trying to do one surface for our overburden. If you come right here on the compositing, we are going to speak a little bit more on the numerical modeling tomorrow about the compositing, but the compositing is basically normalizing your data. So if you have some essays that were taken from some bigger essays, or if you have uneven kind of data, we can make it normalize it by compositing. So tomorrow I'm going to explain this a little bit better with some images too. But right in this moment, we don't need to composite it because we need exactly the points of intersection. We need exactly the points that are being told to us by our data. So now that we have already done, the name is going to be overburden contacts, and we can just do the OK. So now that we have our overburden contact done right here, we could just import it. So when we import, just drag and dropping, what we can see. So we can see right here, and we can try to get the slicer, and we can see right here that we don't have an actual snapping data. It's way too little for us to see this way, but we could check. So let me take out the slicer, and we can see maybe better here and right down here. The contact is not fully being respected. So what we are going to do so the contacts are respected, we are going to go for the geological model. We are going to double click on it. And when we double click on it, we are going to go for snap to data. And our snap to data is going to be drilling only. And why drilling only? Because we only have drilling informations here. If we want this to be based also in polylines, in editing tools that you have used, you can also input all data. But in our case, the drilling only, and the maximum is that distance for 50, it's okay. If you want, you can input on 100, and this way will be more accurate too. So let's just input in the 100. The processing time is going to be a little bit longer, but in this moment, our model, it doesn't have, is not that heavy. So we just need now to click on the OK, remembering that the surface resolution is 10. So clicking on the OK, and now we can see that we have everything way straighter. So let's just check the possibilities that we have right here. So when we create a contact, what we create together. Also, we can create those little middle points of the contact that are going to make easier for us to understand what is the middle point of it and if our surface is right respecting our data right here. So this is the contact points. And we can also export all of those points and check the properties of it, seeing how many points do we have, how much was the processing time of it, and who had created. So if you are checking a project that you have a bunch of people collaborating on that, and you're not sure who was the one that was actually creating the features, all the features on Leapfrog, we can go on the properties and take a look on the history and see who was the one logged on the count on that timing and what time exactly it was. So now I'm just going to clean it all, cleaning all my screen because we are going to carry on. So you can see right here that this is in gray showing inactive. So for making this active, we just double click on the geological model on the chronology. But we still don't have all of our surfaces done. First of it, we will have all of them done, and then we will activate everything in the right sequence. So now we have done our overburden. If you remember, which one was the youngest besides the overburden? We also have veins, right? So we have two veins. One vein system and another actual vein. So if we have dikes, two dikes, and a vein, what we are going to model first? It will not make difference because the both of them are cutting everything. So in this aspect right here, it will not make any difference for you to start modeling the dike or start modeling the vein. So we are going to start by the vein because the dike are going to be a vein system. So at first I can show all the characteristics that we have on the vein, and then we can go for the vein system. So we have here just separated our vein, okay? So on the colors right here on the interval selection lithology, we are just visualizing the vein. Now that we have just click on the OK and we have here our vein, we just need to go to our surface chronology again and ask this time for a new vein. So this new vein, where this can come from base lithology, from other contexts. From other contexts, what this means? This means that if you have a space in two contexts, it can be fill it out with your vein. So from other contexts, from polylines, from GIS vector data. This way we can input the hang wall and the foot wall if you want to, and from points. So in our case right here, you already know we are going to get this from our base lithology, and in our case right here, our vein lithology, it's going to be the vein. So we are going to include the wall points at the end of the hole because this is important for us. But we know that on this case right here, we don't have multiple vein intersections per hole. So we don't have any kind of problem right here with folding veins. So why we have this option right here, multiple vein intersections per hole? Because we can have a fold, and this fold is going to pass several times or more than one time in the same drill hole. If you want to project geometrically a fold, you can start visualizing that on Leapfrog too. So once you have already settled the vein, we are just clicking on the OK. And now we are just dragging this to the scene view so we can check how our vein is. So our vein is respecting our system, is respecting our surface, is respecting our overburden. And if we input the overburden and the vein, we can see right here the encounter of the two of them. And if we want to check out if it's making sense, we can just see that with our data too. Remembering this is just the surface. When we are creating the surface from a vein, we will have more options. So let's just take a look on the options that we have for the vein. So if we go here in the project tree and just expand the vein, what are the options that we have? If we compare right here, you could see that for the contacts on the deposit, we just create some points, and those is the points of contact and the surfaces created by those points. So if you want to edit these contacts, you are going to do basic by the contact points. If you want to edit the vein, you will have several options for it. So at first, I just want to make everything clear, but I'm not going to take everything out, just the overburden, because I wanted to show you a little bit what is going to mean every one of those icons. Why? Because they are important for you on the advanced editing. So if we check out right here, we have the hang wall. If we right click on the vein hang wall, you can see that you can add more information to it. So if you have a hang wall that you have more information on it, you can do a first pass surface right here, and you can add points and add this vector data and add polylines to make your surface exactly the way that you want. Also, you can just edit on it. So we can call up here the edition. We are going to have exactly the same toolbar that we have for the interval selection. And this way we will be able to create a polyline that will cut our hang wall. We can also do the evaluations on the hang wall and extract structural data from it. So I just want to mention because everything is going to be exactly the same for the vein footwall. And one thing that I wanted to visualize is this. Let me just put a bit of transparency on the vein. Why? Because this way right here, we can check how the program is setting the hang wall and the footwall. So if we input right here, the footwall is on blue and the hanging wall is on red. So red on top, blue down. Remember that the on top is not necessarily physical on top, it's the geological on top. So if this is folded, remember that this is the way that you are going to tell to the program that this is folding. So in, for instance, you have two intersections right here. We would have to input the footwall, the blue, on top and the red below if we want this to do a fold. So just explaining here a little bit, this part that I'm saying right now is advanced editing. So generally there is two kind of courses for Leapfrog. We have one that is totally fundamental and one that is totally advanced. What I'm trying to do here is to merge a little bit those informations for you because I think it's very important for you already to be aware how you can advanced editing all of those surfaces because it's pretty easy to do that. And as you can see, it's already available for you. You just need to expand the vein and take a look on what you have right here. And what you have right here is pretty easy to understand too, because you have the hang wall and the foot wall. If you are getting any problem to understand, you just activate your legend that is going to make clear that the hang wall is the red one and the foot wall is the blue one. And if we want, we can also start to do the pinch outs if there is any pinch out in our vein, and also the vein midpoints, the references, and the boundary. Why the boundary? Because the boundary can be very important for us if you want to constrain this vein to a specific place. So if you come right here on the vein boundary, we can also edit this with a polyline. So we could just do a polyline right here to mention on where we don't have data in our vein if we want to. So for instance, we could just edit with polyline, and clicking on that, you can see that something very look-alike on the editing is going to appear, but this time we are just drawing a line. So how we are going to start this? We are going to start right here, draw lines. Sorry. So if we are drawing a line, we can just come up here, click on D, so you will understand exactly what you are seeing. In this case right here, I'm just going to take out some of the things that I'm not using. So I am not using the overburden contact, and we can just create any polyline if we want, and this is going to be our boundary afterwards. So I just wanted to mention with you that this is pretty simple, pretty easy to do. So if you have the necessity to leave your information pretty close to where you have the sample, this is the way that you are going to do that. And afterwards, you just need to save it. I'm not going to save it because for us right here, it will be nice to have the total volume. But if you want to cut this, just save it and you will have on your boundary. And you can also take this out if you want, just going by the boundary, right clicking and delete. So now that we have already discard, now that we have already take a look on our vein, let's take a look on our next veins because we have seen that we have two youngest. We have the dike and the vein. It will not matter if we are going to do the dike or the vein first, but we need to do the dike now because it will matter to do the dike or the other ones first. So I am just going to collapse here our vein and also collapse here our drill hole data. So if you found easier, just come here and collapse all the rows. If you want to do that by our shortcuts, you can do by Control Shift left. So now that we have here our geological model expanded, our surface chronology, we are going to right click and now it's going to be a new vein system. So the vein lithology that we are going to insert right here, it's going to be the dike, and the outside lithology it's unknown. Why? Because there is a bunch of lithologies right here that could fit on that, and we can just leave the unknown. So we just need to click on the OK, and we have a dike vein system. It's empty and inactive. What this means that we don't have anything drowned on this, and it's not activated in our geological um, model. So now that we want to take a look on it, how we were doing that, just taking a look in our data. So I have insert a transparency right here. Now taking out this transparency, editing the colors, and now selecting just the dike and taking out the vein. So we have here the dike separated in dike 1 and dike 2. And in this moment right now, we want to build it like two veins. So we are going to build the vein dike 1 and the vein dike 2 under the same system. So we are going to right click on the dike vein system and we are going to build a new vein. And this new vein is coming from our base lithology. So if we want, we could also use other contact, polylines, vector data, or points, but at this moment, we are using just the information that we have on the drill holes. So dike 1, vein lithology, include weld points in the end of the hole. We don't have multiple intersections per hole. And now just click on the OK. And now we are going to do the same. So from base lithology, we are going to build the dike 2. So first of all, let's just check the dike 1 making total sense. And now the dike 2 exactly with the same configuration and just doing the OK. So now we have here the dike 1 and the dike 2. And we could see that those are interacting with each other, right? So what that means? That means that when we have something that it's interacting is very narrow and it's being interactive to other lithologies. This means that we are not just building a vein, we are going to build a vein system. Why? Because now I can click on dike vein and I can go for the vein system. So when I do that, I can create interactions between those veins. And this way, I can say that the dike 2 it's ending on the dike, on the footwall of the dike 1. So the dike 2 is ending on the footwall of the dike 1. So what we could do right here, we could insert this interaction right here. So we just need to click on them, and then we are going to click on the plus right here, and we can see the interaction type. And we are just going to expand a little bit so we can check what it is. So we have the terminates against dike 1 hang wall, no, footwall. So we have the dike 2 ending on the dike 1 footwall. So now let's just click on the OK. Everyone is following up. I'm just going to click on the OK. And now we have it finishing on the dike 1. We have the right interaction between those two. So now that we have this right interaction between them, what we should do, let's just check against the vein that is with transparency and with the overburden contact. And now we are starting to see our model already being completed. So it's already making some sense. And now we just need to understand what we have missing. So we have already done the dike 2, and the vein and the overburden. So let's take this out. So I'm going to take out the vein, I'm going to take out the dike, and I'm going to take out the overburden. So we can see right here that we have missing the granodiorite and the quartz porphyry and the stratigraphical sequence. So I am taking out the stratigraphical sequence right now for us to understand what is coming first. If there is any porphyry that it seems to be coming first than the other, and it's not. Is another case that we could do the both of them. It would not matter if we do the quartz first or the granodiorite first. But is this is to mention to you that we need to take several decisions while we are doing our model, and we need to be smart. We need to think as engineers, as geologists, and take a little look on the logic of what we are seeing. So here we have everything already modeled into this moment, and now we are going to go for our granodiorite to be modeled. So I'm just going to take this out, and we are going to activate just the granodiorite so we can just look at the granodiorite and how this is modeled. So we already have done some veins that are not active, but they are cutting right here, and the program have already um, understood it since we have already done it as the first lithology. We just need to be aware that when we are inputting that on the chronology, we are inserting the vein and the dike system in the same category of importance. So just clicking here on the OK, we are doing the surface chronology now, and it's going to be a new intrusion. Sorry. So we have here the granodiorite as an intrusion, and we can do this from the base lithology. And in this case, we are just going, you know what? Hello? Oh, so we are going to start actually with the quartz porphyry because the granodiorite will be a little bit more important for us. I wanted to show you a little bit how we could make it together with the plane. So we are going to start visualizing here the quartz, and that's it. We are going to connect these two bodies probably. Let's see what the program is able to do for us in a first pass surface. So we can see that right here we have a kind of data that is sparse. So maybe the program will build just two different bodies, and we know that this is coming together. So now that we have already understood a little bit about our surfaces, we are going to create our intrusion surface from the base lithology, and this one is going to be the quartz, and the exterior lithologies that we will have, they should not be the youngest one, so we need just to separate everything, ignoring the youngest ones. So the newest are the dike, 1, 2, the overburden, and the vein. We have everything here. Just want to check if everybody's following up. We still have not done the GND, which is the granodiorite, so we don't need to worry about it. And now we just need to click on the OK to check what we are going to have as a first pass surface. And this is a point where I wanted to take a little bit of attention to, because we have created here two different and separated bodies. So what I want the program to understand now, I wanted to understand that this right here, it's connected. So let's explore a little bit the QZP and the options that we have. So we can open it, and just taking a look on it, we can see the second lithology. This is not the place where we are going to solve our problem. We can see the surfacing. So if we have any kind of problem with the snapping or how the geometry is behaving, we could take a look on this. We are not going to do that right now. So we have the inputs and we have the trends. So the trends will be our way to deal with that. And we are going to do that by setting a plane. So we are going to set from a plane. We just need now to visualize this plane. And we just need to come right here and start to draw this plane. And what we are going to do with this plane, we will try to intersect it in the most points that are possible. So what we are going to do, we are going to take out a bit our surfaces, because what I'm trying right here is to get everything from my data. So all of my drill holes, if possible, that are intersecting my porphyry. So this is setting a plane is generally the best way that we are going to find to make something in the right direction that you want, because this way I just need to catch this one that it's a little bit lower. So this is the moment where you have to change a bit the angles right here and expand a little bit just to make everything to be touched. So my last problem right here was this tiny little one that is on the right, and now we have everything selected and we can expand it. Just this last one, and now it's almost done. I just need to intersect this last one. And done. Now we have everything being intersected. So we just need now to set from plane. And we have already the plane set. So please just tell me if anybody had any doubts right here. For setting the plane, we can just go right here, or we can come right here and input the set to if you have already a surface that you want to follow. So set from plane is already done. And now we can just click on the OK and see the processing, how it's going to happen. So we have here now our body all connected. So this was exactly what we were trying to reach because we want this to be fully connected right here. So this is a whole body. And now that we have learned how we are going to connect this, I just want to show a little bit the advanced editing. So if you open the intrusion again, we can go for the surfacing and do the additional options. So on the additional options, you will have the value clipping and the interpolant. This part right here, it's more advanced because you need to understand more of the statistics. So you need to understand first of it, the base range, what that means. So the base range is going to be basically the distance between two data points, the double of it. So if you have, for instance, right here, a distance of 60 meters, that is what we have right here, we will have 120 of base range. Our total seal is going to be the same as our variant, and the interpolant is going to be the spheroidal in general, because when we are talking about polymetallic kind of deposits, we are talking about spheroidal interpolants. So the value clipping is also very important. If you want to do the clipping, you just untick this and input the upper bound and lower bound that you want to clip this value. This will be very important if you are also changing the interpolant. You can see the value clipping makes a lot of difference on the variance and on the interpolants. And when we have numerical numbers, we will also have the option of inserting the cutoff and other options for us. That will be very interesting for us to take a look tomorrow on our numbers day. So now just getting on with our categories, we have already done our QZP because I wanted to show you first how we are going to edit the plane. And now we are just going to do the last but not the least, that is going to be our granodiorite. So under surface chronology, we are just going now for the intrusion again from base lithology. And this time we are just using the granodiorite as interior lithology. So what are the youngest lithologies? Everything but the, the sequence. The sequence D1, D2, D3, D4, D5. So we can insert everything here, ignore younger lithologies, and just click on the OK. So now we are going to edit right here on our drill holes because I want just to analyze our granodiorite. So I have here, and we could just take out our first QZP and now go for our granodiorite. So in our granodiorite, we'll have exactly the same issue as we had in the quartz porphyry. So we are going to do exactly the same process. We are going to open it, go for the trends. We are going to set the plane, and for it, we need to see our data, and we are going to build a plane that is going to pass through all over our drill holes. So we just need to come this a little bit upper and a little bit more inclinated, just overlapping everything that is important for me. Also, try to make sure that you are not creating a dip that doesn't exist. So try to follow your data. This part is very important because if you are doing that but you are not following your data or anything that it's already some sort of indication, this can lead you to interpret something that it's not making sense. So we have intersected everyone here. I'm just going to put this a bit closer. And now we are just going to set from plane and OK. Now let's just take a look, and we have a better looking granodiorite right here. And now we have already our granodiorite, we have our QPZ, ZP, we have our overburden, we have our dike system, and we have our vein. What we are missing? We are missing just the stratigraphical sequence. And how we could do that? There are several ways that we could take right now, but I'm going to show you the two ways of doing that, but I think we should focus on the sequence, the stratigraphical sequence, because it's one that you are going to use a lot. So we have here the option new stratigraphy, but we could do by new deposit. If we want to do by new deposit, we will go from base lithology, input the D1, input use below contacts, take off the QZP, and just do by this, and I would create one by one. But we could do that at once. So if you go to surface chronology, we can create a new stratigraphy. And on this new stratigraphy, we are going to input the lithology above, that is the D1. And then we are going to input the D2, the D3, and just click and D4. And the lithology below is going to be the D5. And now we have the D1, D2, D3, D4, and just clicking on the OK. Surfacing, we could take a look on that. And now we could also input right here the bottom contact as erosional. I don't want to do that. We can just input as deposit, but this is something pretty nice for you to be aware, because if you're modeling a layer cake, you can do that just in a few seconds with a new stratigraphic sequence. So just click on the OK. And we have created here our stratigraphic sequence. So let's take a look on it. So how we should validate that? If you take a look on the colors that you have right here, so you should have this D1 color and the D2 color, the D2 color and the D3 color. And this way it goes on. So right here, I should have just the D5 color, because this way I will not get anything that it's unknown. So if you have any kind of unknown basement, you can also add it here. So in this moment right here, when we were doing that, you would just input this as unknown lithology below. So just clicking on the OK, now we have all of our surfaces done. Now that we have all of our surfaces done, what we should do, we should now activate it all. So if we want to activate all of them, what we need to do, we need to at first clean our scene view, which is always good to do, and then we are going to our geological model. In our geological model, we are going for chronology. Why? Because this chronology here is going to dictate everything for us. So the overburden must be on top. The vein, it was the second one that we have done. The dike vein system, it was the third one. The QZP, it was following the dike system. The granodiorite, it was following the QZP. And the stratigraphic sequence is the last one. So now we are going to tick on everything, and then we are going to click OK. For this way, we will be able to start to process our volumes. So first of all, before I do the OK, there is any doubt in any of those surfaces that we have created until this moment? Because this moment right here is very important, because it's when you understand how you do your geological model. So we have done the preparation of data, we have corrected the errors, we have slowly talked about the surfaces right now, and we have created them and edited them. So they are not just a first pass surface, they are also an edited surface. So I hope that everyone is following up right now, because I'm going to click on the OK and we'll start to process our geological model to get our volumes. And after that, we will have our 10 minutes break, because we reach in another hour mark. And also because I can see that the processing here may take a while. No, it didn't. It was kind of fast. So this is what you should get by the end. You can see right here that I have a transparency. So if I input right here without a transparency, this is what I have. So what we need, we can cut it. And if you want on the slice to have exactly 90 degrees, how you're going to do it? On the dip, you are going to change to 90. And then you will have your model right here. So any doubts until this moment? Um, I would believe that this is a no. So we are carrying on in a few minutes, but please tell me if you have any doubts, because this is a very important moment now for us to sort out everything that we may have on doubts about the construction of the geological model. So if we don't have any doubts, I will just take 10 minutes break. And we will come back in 10 minutes. Anything, just tell me, please, and we can go back on it um, when you are all there. Hello, everyone. So I hope that nobody has any problem here in this last part. So we have the slicing tool set on, and now what we need to do, we have already our model done. We have everything separated, and also we have here our output volumes. So let's just take a look on it. So in our project tree, we just need to go for the geological models, the output volumes, and on the output volumes, hello. So on the output volumes, we just need now to drag and drop it to the scene view, and this way we are able to see everything that we have modeled. So we can just take a look on it and see all of the volumes that we have. And what would be our options now that we have our volumes? We can just go on the volume. And for instance, I'm going to take a look on my vein first. So I'm going to right click on my volumes, and I have the possibility to do evaluations within my volume, extract this mesh of the volume. I have how to extract the vertices, just the points of it. I can export it. I can export as a thickness grid if I want it. I can export just the colors, and I can check the properties. So checking the properties, you can see that this is totally closed. So it means that I will not have any problems on my further processing because this is totally closed and consistent. I have here the amount of triangles, the volume, and the area of it. So what that means? That means that I already have a volume. If I had here a density, I could already have a grade. I could already have tonnage. So this is how easy we can get informations when we have a good tool for us to use. So here now just closing a little bit, I just want to show you that we are pretending here that we are in an exploration campaign in a campaign, and now that we have done this first phase, we also need to make some analysis along with this with this. And what we can do, we can now take a look on how we can store this volume, this geological model right here. So if we have here the geological model, we can right click on it, and we have how to create an static copy. So we are going to create an static copy, and it's going to be called the GM phase 1, and with the today's day, because we need to make this an archive for us to understand what is happening. And now we just need to click on the OK. So now that we have created a static one, what we can do, we can take a look on it and see that we cannot edit anything. So on the static version of it, we can take a look in everything. We can make calculations with it, but we can no longer edit it. So that means that if I change the information that was used to do the GM phase 1, I would also change my model right here. So this way, doing an statical one, we are not going to change if we are going to reload or append more information. So now that we have our geological model, let's see what else we have in our little data file that could be interesting for us. So we are going to import from file right here on the drill holes. We are going to import from file interval values, and it's going to be importing drill hole data additional table. We are going to go for the weathering. So we just need to open it, the hole ID, and here we are going to import it as a category. So we have right here, and we just need to finish. So let's take a look on our weathering informations right here. I am just going to take off the visualization, and we are going to check our weathering. So in our weathering right here, we have mainly three categories, and the categories are going to be the fresh, mixed, and oxidized. So we just need to come right here on the legend and take a look on the fresh, oxidized, and mixed, because we want to model it. And to do so, what we should start doing. So we have this already done. The only thing that we should do is to take a look on probably errors. We have here just warnings. So those warnings doesn't make sense. We are not seeing the same um, drill hole. And here, what we should do, we should just come right here in the geological models, right click on it. We are going to do a new geological model, but this one is going to be based totally in our weathering. So the base lithology column is going to be our weathering. The surface resolution, it's going to be 10 to. Enclosing object, we are just going to input our OL drilling phase 1, and we are just going to set here for weathering. And now we can create a weathering model and understand where our surface is more weather, where is less weather, and this way, this will be also important for us in the grades analysis, because we need to have an understanding of what is what. So if you have, for instance, something that is oxidized, or something that maybe have less hardness and resistance than other parts of the rock, you can start by there. So this is going to make a lot of difference on your production afterwards, and we can combine those models afterwards. So following the project tree, you can go and check that we can combine models. So if we do a pit model, if we do a weathering model, if we do a geological model, we can combine those models, and this way we'll have exactly the amount of the domain that we are going to take off from the inside of the pit, for instance, or we are going to have the exactly amount of waste that we are going to take off from the open pits. So this here is very resourceful for us, and we are going to use it in the next steps. So now that we have here our geological model for the weathering, we can start by the lithologies, because we know that we have those three lithologies right here, and how we should start modeling it. If we think about it, we need to take a look on our data. And on our data, the oxygen would be a deposit on top, like the overburden, and afterwards we will have the mixed and the oxide. So we are going to start by doing the surface of the new erosional uh, a new erosional deposition from the base lithology, and it's going to be the fresh one. So we are going to use the contacts below, and those are going to be the contacts below. So this is the mixed and the fresh contact, and we are just going to do the OK. Oh, I'm sorry, I have confused it. Is the fresh one that we want to do right now. So we are going for the surface chronology, and we are doing the new erosion from base lithology, and it's going to come the first one, that is the oxide. So we are seeing right here on top is the oxide, and we need to use the contacts below it and just click on the OK. And now we have our surface for our oxide. So now we just need to do our second one, which is going to be the mixed. So to do the mixed one, we are going to use a new intrusion. It's going to be also from base lithology. So let's just click on it. And in this case, we are using the mixed. And the exterior lithologies are going to be the fresh and the oxide. The oxide I'm going to ignore as a younger lithology. And now I'm just going to click on the OK. And we have right here the surface covering everything that we wanted. So now we just need to activate all those surfaces, and we will have our weathering model also ready. So we just need to go for the weathering model. On the chronology, we just tick everything. The background lithology, it's going to be the fresh, and we just need to click on the OK. So you should have something really look alike mine. If we have some few difference on it, there is no problem. But basically it should be very look-alike. So now I'm just need to take all these visualizations, and we can take by cleaning everything out and going for the output volumes and calling for the mixed, the oxide, and the fresh. And here we have our little model for the weathering. So now, just taking everything out, I just want to be clear. Everyone here is following up. We are in the same stage. There is anybody that needs help to get in the same place as me? Mm. So for now on, we are going to start using uh, the extra data that we have, and we are going to update our model. Why? Because we have several options for updating, and we are going to try out. So I have already made a static copy of my phase one, because this right here is just going to become my main geological model. It will be basically the GM geology. So we can rename it. We have the geology, we have the weathering, and now we can just come right here on the drill hole data, because we may find more data for us in our archives. So if we take a look in our file, the Leapfrog Geo Fundamentals course data, we will have right here the geological modeling dynamic updates. So if we come right here, you will check that we have how to import more information here. So we can start by the weathering. We can just take a look on it. So if we right click on it, we can append data or reload data. So at first I am going to try to append the data. So we are in the weathering. Right click on it, and we are appending data. So now that we are appending data, we just need to go for Leapfrog Geo, dynamical modeling updates, OL weathering, phase 2, and just do the OK. So when we are importing more of this data, we are also seeing this little window right here where we can see all the information that we need from the headers. And now we just need to click finish. So we have already a problem right here and we can go for the fix errors. The whole ID is not in the table. So what that means? That means that we should reload the data also in our drill holes. So now that we have everything here, we just need to come in our drill holes and import our data. In this case, we are reloading our data. Why? Because now we have more information. We want everything. So we are going to get the OL color all, open it, and we will have everything following the same pattern. So we just need to click on the import and we can see that now we need to take a look on the headers. So the not imported one, this is the whole ID and we could see that this is just a character problem. So we just need to input that this is our whole ID. The drill hole type is not important for us right now. The TD is not important for us right now. So we are just clicking on the next. And here we have everything settled. We are just going for the next. Not imported is because we need to input as the whole ID. The whole ID is very important to be inserted for our data to work. And the next one, the stretch and the simple lithology, which are continuing to be the lithology and will be also updated in our model. So now we just need to click on the finish and we will have our table updated. So now you can check that the errors that we have on the weathering had gone, because what I wanted to show you is that when we are appending data, we are appending in the same drill holes. If we want to import more drill holes, we will have to import it and reload it. And now we were getting that error. If you check the video before, you will see that that error was caused by the lack of information of whole ID. So carrying on, now we are seeing that the processing is being done, but we have some analysis that we have done previously, right? So let's just take a look on the group lithology. And on the group lithology, we need to edit the colors and check if we have any other Ng granodiorite intersection that was not grouped, and we don't have it. And now we just need to take a look in our intersection and our interval selection group and take a look on the dikes. Why? Because now I have here the dike just, and I want the interval selection done for my vein. So what we are going to do now, we are going to complete this interval selection that needed to be completed now. So one thing to be aware when we are checking our data after have inserted, if our data is still following the rules that we have settled for our modeling. So in this moment right here, it's important for us to separate perfectly what we have for the dike 1 and the dike 2 again. And we have already this with intersection on it. So we have the dike 1 ending on the footwall of the dike 2. And now we just want this to carry on. So remembering when we want to do an interval selection, what we are going to do, we are going to edit. So we just click here to edit our interval selection. So editing it, if you want to stop editing, just click here again. If you want to come back, click here. So we have here our dike and our dike 1 and 2. So I'm just going to tick out the dike 2 for us to understand what it's following the same pattern. And if we want to make a better visualization, we can again do the splitting. So we are going to do this slice right here. Oh, sorry. We are going to do this slice right here and select what is going to be our dike 1 and our dike 2. So right here, we have our dike 1, and we need to assign to dike 1. And here we have our dike 2. So I have done, oh, sorry. I have done on this side. Now I just need to do on the other side. So just arriving here, and we are going to select the dike 1 and assign to dike 1 and select the dike 2 and assign to dike 2. So right here, let's assign to the dike 2. And now I just want to take a further look to understand if those last ones are from the dike 1 or the dike 2. So we have here a misconception. To change it, we just need to go right here, assign to dike 2. And now to understand better, I am going to save it. And edit the colors to see the dike 1, dike 2, and the dike. Just clicking on the OK, I'm going to make the slicer now for the bottom. So we have right here our last segments. And they are following basically if you want to go a little bit upper with your slice, you can. So just on the slicer right here, we can just go a little bit up and a little bit down. And realize that this is making part of our dike 2 maybe. So we are just going for the interval selection right here and selecting it as the dike 2. So we have already our dikes reselected. We can now untick everything to see if this is making sense or not, if this should be part of the dike 1 or the dike 2, and we can just take a look right now. So if you want to take a better look, what we do, we take a look from down and select a place to do the slice. And now that we have the slice done, we can follow from this side to the other side if this is making sense. So those ones right here, we need to check because they seems to be on the dike 1. So we are just going to open, do the interval selection editing, and we are just going to select it for the dike 1. And then we are just saving it. All the times that we are saving it, just remember that all of our geological model is also being redone because we have already modeled the dike 1 and the dike 2. Those surfaces already exist. So we are having right here so just to check, can you hear me? Are everybody hearing? There is anybody hearing? There is any problem with the audio?
Yes, we can hear you.
Oh, perfect. No, it's just that you got a little bit quiet, and I was thinking if maybe the workflow is too hard, if you got lost or something. Please just tell me if you are having any kind of trouble, because now we are really getting into the geological modeling, and I am starting to get with the pace a little bit faster. So it's just to be aware if it's okay. If you want me to slow down or be a little bit more basic, there is no problem on that. So just going further now, we have already selected our dike 1, dike 2, see the grouped one. And now what we are going to do, we are going to check out our geological model because we need now to set our boundary to our new boundary because we have more information. As we can see right here on the color, we have way more information, and we can compare now the phase 1 with this new information. And remembering the phase 1 is stored already. So right here, we just need to go for our boundary in our geological model. We need to open it and enclose objects, but this time to our new color. And now just clicking on the OK. And we are finding some errors. This is pretty common, and when we are finding errors, we can just take a look on them right here. So when we have any kind of error that it's related to something that we cannot process, the program will stop the processing, will make red, and what we can do when this happens, we are going to right click on it, and we are going to go to the project tree or show the error. So we can go for the show the error. Cannot build a curved reference surface with no input points. So what it's telling me right here, that this probably wasn't the dike 1, this was the dike 2. So this is exactly the point of trying out when you are seeing a new geological model that you are going to do. So maybe selecting some parts that you are thinking that are part of this lithology, maybe selecting other parts of it. But the important part to be aware right here is that you will not have any trouble to follow up if you are trying just to do any tryout, because you can just come right here and redo it. So now that we have right here our problem 1 with the dike, and we can open it and see that the dike midpoints doesn't make a reference that it's curved. So what we are going to do, we are going to change this reference because it's not making sense. And this had happened when we try to change our boundary. So what we are going to do now to enclose this boundary again so we don't have any troubles, we are going to input on the OLEC. So when we do that, we can see that we have also a boundary that it's on the Z axis. And now let's just do the OK. So we are having the processment right here. And if we have any kind of trouble, the program will show us. So this processment time can take a little bit longer depending on your hardware. Don't be afraid of it. There is no problem since you remember the rules that I have already commented with you. So if you are doing a tryout, this is the first time, it will not make sense for you to already input a resolution that is going to make your processment way too heavy. You are doing a few tryouts. So in this moment, you don't need to actually do a super accurate model because you are still trying out, you are doing the processment a few times. So you need to check if it's going to be, if you need to control it. You need to be able to control this a little bit better. So now that we have already processed our new geological model, let's take a look on it. So now we have our geological model exactly expanded for our new information. All of the rules that we have settled, it's already done. So one thing, the first thing that I wanted to mention, thing number one, when we have settled the boundary box, it's pretty common we have boundary box and that it's going to show you on this error on the processment. So when this happens, don't worry, just go to search where the problem is happening, if the problem makes sense, and if you change, and if you should change something on the way to make it fit better. So now that we are here, we can just take a look on it and see how this is fitting better since now we have selected a boundary that also have this elevation that we needed. So when I have selected just the color boundary, we didn't have this profundity. So now we have it. And that's the important part for our processment because we are talking about creating volumes. So now that we have already updated our model, we have how to compare our model to, because we can compare the phase 1 with the phase 2. So if we just make this a bit transparent, we can try to do a slice on it and see how things are actually continuing. So what that means that if you have a good visualization of your geology, if you can do the first surfaces and edit in the best way for you to understand it, you will be able also this way to always update your data without having problems of having to do everything once again. So this is going to be the mainly workflow that we are going to use to do new phases, to do open pits, to combine models. And now we are just going to go for our last, but not the least, uh, little model that is going to be our open pit model. So we are going to do now is that we are going to go for meshes, and on the meshes we are going to right click on it and import mesh local. We can see right here all the formats that we have for those meshes. So we have a DGN, OBJ, DXF, DWG, DET, ARA, DTM, LMF, PS, DM, Mesh, and Tree. So if we are talking, for instance, of a OMMF kind of mesh, what we could do, how we could bring that on. Answer, tell me.
In a second phase, any new lithology encounter, then how will add this?
Sorry, could you
If
repeat
any
it?
new lithology encounter in a second phase, then how will add this? And how will
Okay,
update the model?
you will do exactly the same process. So
No,
you
not
would
same
update
process.
it.
I,
Yeah, no, yeah, just hear me. So you will do exactly the same process, but afterwards you would go for the surface chronology right here on your stratigraphy sequence. So for instance, if there was one more sequence for you on your stratigraphy, you would come right here, open, and just add the lithology. If it was another vein, then you would maybe have a problem if this vein was cutting through everything, because that means that your first model is also wrong, because the vein is the youngest and is cutting everything. So if we are talking about new stratigraphical sequences, it's going to be pretty easy because you are going to import, do this on your stratigraphic sequence, or you are going to create a surface chronology, new deposit, and from your base lithology, you are going to construct your new lithology, your new surface. And if you have, for instance, an intrusion, you are going to do the same. Right here on the intrusion, you are going to open and do a new one. So in this case right here, if you have an intrusion, if you have a stratigraphic sequence or a sedimentary kind of basing, if you have a kind of vein that is not actually messing all the chronology, but of course, what you could do also, the tryouts. So if this is a vein that is cutting everything, you can try to do a vein. And right here on the geological model, on the chronology, you will change the chronology from the youngest to the oldest again, because you are adding a new vein in this uh, pretend scenario. And you will reload, you will do that again. Tick everything, do the OK, and everything will be upgraded to this. And what it's important for you to be aware, the chronology. It's the only thing that you must be aware. If you are adding any lithology, be aware with the chronology. If the chronology is changing, it's because the logic of your system is also changing. So we have to think here with logic. Always get a logical thought. So if we are starting in one way, how we are going to get to the way that I wanted. So if I need to add more information, how am I going to do that in the way that I wanted? Because remember, your result is only good as your data and only good also as your analysis. So if, for instance, if you know there is new lithology and know how to do these new surfaces, or you are not afraid of do some tryouts, this is not going to be any problem for you to update your phase one model. The worst case scenario here would be for you to try to do again your geological model. But once you have already the ability to do that, you can actually build a geological model in 2 hours. So uh, I think that I have answered you already because you have asked about the new lithology when we are trying to input if we have append a new lithology with this drill hole data, right?
yes,
Yeah, so you will be mainly it. You are able to understand?
yes, yes.
Well, thank you very much for your question. It's just that I'm thinking that maybe we should go now for the open pits and just getting everything from the scene. My computer is doing a really loud noise, so I was just a little bit worried if my screen gets stuck because of it. So please tell me if my screen gets stuck anyhow. So now we are going for our open pit model. We have done a weathering model, a geological model for our second phase of our drill holes. We have here the insertion of the first phase of it. And now what we want to do, we want to create an open pit model. So for it, we need at first of the mesh of the open pit. So if we take a look right here on our geological modeling, we can just check the design simple pit surface right here. And what we could see that this is on ONMF file. When we have ONMF files, I have already mentioned with you that sometimes we have some types of volumes and meshes that will be better to be imported as designs. So we are going to collapse our row right here, and we are going for the designs. And on the designs, I am just going to right click on it, import designs, and we are going for the Leapfrog gel. No, no, no. And we will see that on the designs, we will have just the DWG, DGN, and DXF. Why? Because we are talking about an OMF kind of file. For an OMF kind of file, we will have to go right here on the settings and go in OMF, import, and on this place, we are going to go for the geological modeling pit shells and just selecting the OMF right here and opening. So we just need to select it and subscribe and do the OK. So we have here being processed, and we have here the design of our simple pit surface. So please tell me if somebody wasn't able to import this surface right here. So we have here our example of open pit, and now we have how to take a look in our model if this was going to make sense or not. So we have here our open pits, and we can check that to fit our open pits in our geological model, we still need to make the boundary larger. And every time that we are making the boundary larger, we are also enhancing a little bit of the time of processment. So right here, what I wanted to show you is that we will have to do this enlargement of the boundary, and this is something for you to check out on your projects too, if things are fitting, because if they are not, you just need to come back to the boundary and change the boundary by open it and expanding here just a little bit so it can cover all the open pits without any trouble. And then we can just click on the OK. So now we're just going to take out everything that we have here on scene, and just the pit is going to be here because we are processing now all the rest of it. So now that we are on this processment time, to give a little bit of time for my computer, we are going to get in the last break. If you have any question until this moment, we are going to finish it with the modeling of the open pits, combining the open pits with the geological model, and then the last Q&A section for the day. And of course, by the end of this day, and maybe on the beginning of the next one, because it's being really heavy to upload this recording file, I'm going to share the project of today and also the recording of today. So, but please, if you have any question, it will be better for us to do this live. It's always better to take the doubts on the moment of the class. So we have already done the processing right here, but I was still going to have to give you the 10 minutes of break. Please tell me if you got doubts in any place right here, if you want to re-see anything, or if you're having any error here that doesn't have appeared to me. This can happen. And we are going to see each other in 10 minutes then. I'm just going to fresh up a little bit and we'll be back. So coming back with our model, and now we are going to create with our open pit right here, our drowning. Remember that this could be imported from the designs or from around here, the OMF. Here on the settings on Leapfrog, when you click on this corner, OMF is going to be the only option for you to import. So if you want to import different kind of designs, import designs. It's right here that you will see the options that you will have for this. And of course, you could also do that on importing meshes, but not an OMF format. So here you could support all of those here, of those formats. And the OMF specifically, we would call right here. So now that we have here our surface, now it starts again our geological model. So we can go and just do a new geological model. And in this new geological model, our base lithology, it's going to be none. Why? Because we don't have any lithology to search for this. We don't have any, we just want to know what is inside the pit and what is outside the pit, right? Because this way we can already do a volume calculation of what is inside the pit and what is outside the pit. So we have built it today a geological model, and we are going to combine it with another geological model that we are going to build. But this one is totally categorical for what is inside and what is outside a pit. So we have here the pit, and we have here our name that is going to be geological model open pit. And now to enclose the object, we are going to choose the boundary that we have here for our geology. So we just need to go for the geology extents that we have already fixed. And it seems to be approaching everything. And then we can just click on the OK. So once we have it, let's just take a look right here in our project tree. Just take a look on your GM open pit and just drag and drop. We have here the volume, the total volume for it, which is very important for us. So the first part that it's important, the boundary, it's right. The resolution, it's right. We have settled for the same resolution as as our geological model. And now we just need to start creating our little model that it's going to be about what it's inside and what it's outside the pits. So this way we can combine it with our information from the phase 1 and 2. So now that we have already our block model right here, we just need to go for the open pits and go for the lithologies and double click on it. So once we double click on the lithologies, we are just going for the plus sign where I am going to describe pit and outside pit. And we can also exclude the unknown if it was possible. And the pit and outside pit is what's important for us. So now we are just going to click on the OK. And we are going to go for our surface chronology, a new intrusion. And on this case right here, we have it from a surface. So we just need to go from a surface and we need to select this data. And where we are going to get this information right here from our meshes is right here, the design simple pit surface. So we just click on it and do the OK. Just click on it. OK. And then the first lithology, which is classified as younger, is going to be our pit. And the second lithology is going to be our outside pit. And now we just need to click on the OK. and take a look if it's making sense. We just need to put some transparency, and we have here our mesh of surfaces separating one thing from the other, but we still didn't have activated it on our geological model. So we don't have two different volumes right here. We need to go for the geological model, double click on it, and just input now that we want to snap to data, all data, because in this case right here, we are not using drilling, we are using a mesh, and also that we want it activated. So the background lithology right here is going to be the outside pit, and we just need to click on the OK. So right here, we just need to input the pit, the outside pit, and we have the volumes that we needed. So if I want just to take a look on the pit, we could, and now we have a volume for our pits. So I could just go here on the pits and do evaluations, and I would be able to do evaluation if I have any numerical number already attached to it. And we can also do the properties, and on the properties is where we are going to get the volume. We could get it on the evaluation if we already have attached the numerical numbers and numerical modeling that we are going to dive in tomorrow. Why? We are going to have now 2 days of training. So that means that in those first 2 days, you are able to get all the basic. So you can insert your data, you can correct your errors, and you can get to a geological modeling. So tomorrow we are going to speak about when we are trying to input categorical data and numerical data together, when we are working just with numerical data, and what we have as statistical tools for making our projects better, and also to indicate where we have more or less ore. So this part that we had tried out yesterday and today is about data insertion, correction, and categories modulation. So we have here basically a lot of information, and now we are just going to combine this information. We already have the total volume, but we could get now the volume for each lithology. So we just need to go for the combined models. I'm just going to make everything clear now. And on the combined models right here, we can do a new combined model, and I can choose the one that I'm going to use. And we are going to use the geology and the open pit one. And the combined model will be open pit and geology. And just clicking on the OK. So now we need just to select the volumes that we want to combine. In our case, we just want the inside pit. We don't need anything that is on the outside. And we can select every one, every single lithology if you want, and just click on the OK. So now we are processing, and we have already our model combined. So we have here our little legend and the output volumes right here. So on those volumes, you could export just this volume. If you wanted, you can change the colors, you can check the property where you can see the volume and the area. You can extract the mesh parts, and you can do evaluations once we have already something from the numbers right here. So the numbers that we have right here are the assays for copper and gold, and we are going to check tomorrow how we are going to do to from a first sight to understand what is attached to what. So we have a still spare time today, so I could start talking about it if you want it, if it's not too much information for you. But if you prefer just that we talk about today, and if there is any doubt about it, if you want to comment or add something, please. So since we don't have any doubts for
And
today, oh, sorry. Tell me, Arushi.
yeah, yes, I was saying that for today, I think that is like this much is enough so that we can
Okay,
uh,
Logistics.
digest and understand. And
no problem.
yeah,
Perfect. No, it's just that I want to be aware because I can see that you are a bit quiet today, and I'm not sure if it's because it got really hard or it's too easy, because people can lose their attention too if it's too easy, and then then we can get a little bit harder. There's no problem. It's just that I know that it's a lot of information, and what I think is more important for you to understand now is that is the main information. So if you
yes,
understand pretty well what I have said yesterday and today, you will be able to do everything that you want. So with the tomorrow, I will bring more advanced um, commentaries too. So with all this information, you are able to already launch your project, because if you find problems on your project, this is normal. We find problems all the time, and you have right here the support. Contact us to tell us if you are finding something that you cannot go over, if it's something that is not making sense, if you think the software is not handling right the geometry or things like that, we can act on it. And of course, if you don't know about something, oh, I don't know if I can do this kind of calculation, I don't know how I'm going to do this calculation, you can also call the support, and a call no, it's just the email. You can email the support, and we are going to answer you a little bit with the workflow, how you could sort that out, if there is a problem from our side. And this is the perfect workflow for you, because you have the tools that you need, and now you just need to go and build your project little by little. So since it's a lot of information, I am going to leave here for today. I am going to do the same as yesterday, but sorry, there is no option on Teams to share the recorded. So I will have to download it again and share through the share file. I think that, uh, please tell me if anybody had a problem to download it. I know that it's a little bit heavy file, but unfortunately, I didn't
no, it
thought
was
about any
easy.
solution.
That was
Well,
fine.
glad to know.
Yeah.
Oh,
Hello.
uh, hello, answer. Tell me.
Yeah, if you share the recording little bit early, then we watch the recording. Accordingly, we will do the practice and ask the question if we face any problem.
So I can see the recording, and I can see that it's not possible to share. It's saying like the people must be part of the same institution. So I think the domain of the email should be all Bentley, and this way we could share. But I wasn't able to share this way. But since Arushi have commented that it had worked to get from the share files, anyways, on the last day, I'm going to send the 4 links. So for the 4 days of recording, and also the 4 links with the 4 projects. Day 1, day 2, day 3, day 4. We are going basically to make the same project each day better, but I know that sometimes you are trying to see some specific issue that maybe it's better for you to take separately the days. So it will be mainly that. Uh, there is any questions? Any more doubts?
Let us like practice ourselves, and then we can maybe ask some questions. That would be easy.
Okay, perfect. So, you would like for tomorrow to have a more slower pace?
Yeah, a little bit.
Okay. So the next time also, just stop saying, I am not following up, please, a little bit slower, and there is no problem. The good part here is that we had covered what was the most important for those 2 days, and that's the main objective here.
Yes.
Well, so thank you very much to you all. We can, tomorrow you also want to start 15 minutes late, so
No,
you
no, no.
can have proper lunch.
No, not tomorrow. We can start by 2, like 2 p.m. It's fine.
Perfect. So tomorrow, 2 p.m. for you, we'll be there.
Okay.
Bye bye.
Okay,
Thank
thank
you very
you.
much
Bye
for
bye.
your
Thank you
time
so much.
today.
Thank you. Thank you so much.
You're
Bye.
welcome.